Okay, guys, this is part one, okay, of the materials covered in exam. So we go back to the notes first, and it is talking about the classic experiment to prove, okay, formation of compound from two elements. Okay, so it is iron and sulfur, and I think that for the color and action of magnet, I don't think I need to go through it very deeply because you know the color, and you know iron will attract with the magnet, but not the sulfur powder. And when you heat it up, okay, a new compound is formed, okay, and you must, guys, okay, pay attention to this one. You must conduct experiment in the film cupboard, because a toxic gas, okay, sulfur dioxide, will be produced. It's not because of the reaction with iron. Actually, when you heat up when you heat sulfur, sulfur will react with oxygen in air to form sulfur dioxide, and sulfur dioxide is toxic and is a very smelly gas. Okay, we use the word pungent. Okay, and for the product it form, okay, iron sulphide is black in color, and it will not attract by the magnet, so it proves that a new substance has been formed. And this is just the summary. I think I can go through it very quickly because it's very straightforward. Okay, so this is the conclusion. Girls, pay attention to for the chemical change. For example, water. When water is electrolysis of water will produce the constituent elements hydrogen and oxygen. So I give one more example here. Okay, of course it's not in the book, and it is silver oxide. For some chemicals, you can directly heat it up and it will break down into their constituent elements. Okay, so for the separation, not in exam, so I think I can just skip it. Guys, this one is more important, okay, than the experiment. It's about the comparison in chemistry between compound and mixture. First, we talk about something that you know it already. First of all, the properties, okay. Of course, compound has a total different properties with the constituent elements. Just take water as example. Water, H2O, okay, is come from hydrogen, H, and oxygen, O, okay. And in terms of their physical property, water is a liquid, while the two constituent elements of water, hydrogen and oxygen, are gases. And talking about the chemical property, hydrogen is explosive, oxygen helps burning, but water is used to put out fire. Okay, so they have a totally different properties. But for mixture, it can retain, guys, okay, retain its own properties. Just like the sulphur and the iron, okay, when they just mix together, when you are attracted by the magnet, only the iron powder will be attracted by the magnet. And the separation, of course, for compound, it can separate it by chemical methods but not physical method. For mixture, it can only separate it by physical methods. Next, the composition scales, okay. For example, water, you know the chemical formula H2O. In case we have 1 million particles of water, the composition of hydrogen and oxygen is still 2:1. Okay, hydrogen and oxygen is still 2:1. So it means the composition of compound is fixed. No matter how many compounds you have, okay, the composition is fixed. For mixture, okay, it can vary. For example, iron and sulfur, you can just have a little bit of sulfur and so many irons. So, or vice versa, you have so many sulfur but just a little bit of iron. Okay, they are all the mixture of iron and sulfur. Okay, mixture 即係你中意落幾多都冇乜所謂嘅。OK，譬如一個 mixture of iron 同 sulfur， 有少少 iron， 好多 sulfur， 好多 sulfur， 少少 iron， 都係叫個 mixture of sulfur and iron. So it can vary about the composition. Next, about the heat change. Guys, in case there is chemical change, okay, just remember, in case there is chemical change, heat will be absorbed or released. Okay, heat will be absorbed or released if this is a chemical change. And you know it, the formation of compounds from their constituent elements are chemical change definitely. So it will have the heat absorbed or released. Okay, heat will be absorbed or released because this is a chemical change. And you know, for mixture, you just mix it up physically, so no heat change. Okay, no heat change normally. Lastly, about whether the compound is pure or not. You know, mixture is not pure. and you know compound is pure. Guess if the substance is pure, compound elements, they will have a very, very sharp melting point and boiling point. And by speaking of sharp melting point or boiling point, within 1 degree Celsius, it will change the state completely within 1 degree Celsius. Of course, the definition, no need to remember 1 degree Celsius, but you need to know if it is pure substance, compound, for example, it will have a very sharp or definite melting point and boiling point. But for mixture, in comparison, because it's just mixture, okay, it is not pure. For impure substance, it will melt or boils in a wide range of temperatures. Okay. Next, about 3 daily life compound. I think I don't need to go through it, okay, because it's so simple, guys. Okay. The ratio of the constituent elements. Okay. If we don't state it, it is 1. Okay. For example, NaCl 1:1, HCl hydrogen to chlorine is still 1:1. Okay. I don't think I need to go through it. Next, about elements, girls. Okay. For the classifications, we classify into 3 different groups: metals, non-metals, and metalloid. Metalloid means semi-metal, girls. Okay. Again, don't challenge yourself. Semi-metal is good enough for the answer. Okay. Of course, you can spell metalloid, but metalloid is the same as semi-metal, and I think you know how to spell semi. Okay. So I think this will be an easier option. Metals, good conductors of electricity. Non-metals, non-conductors. Guys, you need to remember the exceptional case, graphite. Again, you need to remember the exceptional case. Graphite is the only non-metal that you know that conducts electricity. Okay, and you know that graphite is actually carbon. 石墨其實係碳嚟嘅，石墨係唯一一個導電嘅非金屬。For metalloid, very special, okay? It has a bit of low electrical conductivity, but it is useful still, okay, in the computer chips. Okay, in the computer chips, transistor, in the industry related to computer. Okay, metalloid. Remember, guys, one very, very important semi-metal. You will learn it in chapter 6 again, okay? But I tell you how million times, please get to know silicon. Spell the word silicon, okay? Silicon, germanium are the 2 examples of semi-metals. Okay, this one, guys, this table helps you a lot to identify. Metals are shiny, okay, when they are freshly cut. Now you know why we put freshly cut, because for group 1 metals, they are not shiny. But the reason why is because the surface of the metal reacting with the oxygen in air. But when you freshly cut it, all the metals will have a very shiny appearance. But for non-metals, they are very dull, okay, 好啞色同埋好吝色 okay? 切開吝色一定係 metal， 好啞嘅。係 non-metal, okay? And the electricity, the electrical and the heat conductivity, metals are good conductors of heat and good conductors of electricity, while for non-metals, they are poor conductors of electricity and poor conductors of heat, except for graphite. Graphite is a good electrical conductor, okay? Graphite. Okay, is the only example. Guys, malleability, ductility, you know it in the first lesson of chemistry in Form 3, but please specify. Okay, 拉長撳扁，邊個拉長邊個撳點啊？邊個撳扁啊 ？Ductility means 拉長 ，malleability means 撳扁。Okay, malleable and ductile， 邊個拉長邊個撳扁要清楚。Ductile pull into wires, that means 拉長。Malleable, roll into sheet, that means 撳扁。But for solid, okay, for solids of non-metal, guys, they are brittle, 易碎的 ，okay, 好易碎嘅 brittle, okay. Non-metals, the solid of non-metals are brittle. Last but not least, melting point, boiling point. Most of them have very high melting point, boiling point. Except for mercury. Mercury is the only metal that is in liquid state. Okay, for the liquid state elements, you need to know mercury is the only metal that is in liquid state, and bromine is the only non-metal that is in liquid state. Okay, we have only 2 elements in liquid state at room temperature, 25 degrees Celsius. In comparison to high melting point and boiling point of metals, non-metals will have a low melting and boiling point. Okay, it is compared with metals. Next, I mean just some very basic you just need to memorize it. Guys, I suggest you to memorize for the most abundant element in the Earth crust. It is not the air, not the air， 係地殼入邊，唔係個空氣。OK， 地殼入邊最abundant many that means contain so much。OK， contain the most amount。地殼入邊邊隻 element 最多啊 ？Oxygen。OK， 最多。地殼入邊邊隻金屬最多啊 ？The most abundant element, the most abundant metal, aluminium. Okay, I mean for the trend, you just briefly remember it. And the use, I don't want to go through it, girls. Okay, for those of you, for those of them I highlighted, they are well known. They are well known. Okay, to you, but I think you yes, I think you can just remember it. For the symbols, girls, okay, again, for non-metals, usually one letter. For metals, usually two letters, except for noble gases. Okay, except for noble gases. And I told you, 乜乜 lium 乜乜 lium 嗰啲通常都係 metal 嚟嘅。乜乜 gon 乜乜 gon 乜乜 rin 乜乜 rin 乜乜 jun 乜乜 jun 嗰啲咧，通常都係 gases 嚟嘅。Okay, but again, not always true. And for the chemical symbols, okay, sometimes a bit tricky. For those of them I highlighted in with the star, the blue star. Okay, they don't use the first two letters. Okay, they use the first one and the third one. And some of them in Latin. Okay, I mean, girls, I think you should know. Now you should know sodium and potassium. You must know it actually. You must know it. It is in group 1. Okay, I mean because, and yes. Next one, how to judge, okay, each type of atoms. I think you can refer to this one. Okay, for example, I ask you, how many atoms in this compound? You just need to 2 multiply, because this bracket means 3, everything inside the bracket multiplied by 3. That means 2 plus 3 times 1 plus 3 times 3. That will give you, okay, 2 aluminium, 3 carbon, and 9 oxygen. Okay, that will equal to 14. Okay, that will equal to 14 atoms. So that's how you calculate. Okay, for more difficult cases, guys, I think you can read the notes here again. Okay, I don't want to repeat because otherwise it will be too long. And now, girls, we directly go to the book chapter 5. And the first part of chapter 5, okay, I mean for 5.1, 5.2, 5.3, actually it is more or less the same as the note. So we directly start at 5.4. And for 5.4, the first one is the structure of atom, the atomic structure. And for atomic structure, girls, okay, you have 3 subatomic particles. You must know it. 3 subatomic particles. Protons, neutrons, which is inside the nucleus, represented by this purple ball, okay? And the electrons, girls, electron, it is the green one. Okay, I mean of course you may wonder why it is electron cloud, but it is too difficult to explain in form 3. You can just treat it as a normal electron. Okay, 你當一粒粒得嘅，你唔好當一嚿雲。Okay， 當一粒粒就 OK 啦。So proton, neutrons found in the nucleus 中間嗰度 and electrons will move around. Okay, will spin around, will move around the nucleus. Okay, of the atom. Okay, proton 同 neutron 咧就喺中間嘅 ，electron 咧就喺側邊圍住個 nucleus 轉。Okay, this is the structure. And guys, we are talking about 2 things here. Okay, of course the position I've already go through it. Now the symbol is just the first letter. Okay, but for electron, why we put a minus here? Because of the relative charge. Guys, again, this is just relative. Okay, just relative. A comparison between something. Okay, proton 同 electron. Okay, in comparison, proton has a +1 charge, electron has a -1 charge. But for neutral. Okay, 中指中性. Okay, it doesn't have any charge, so 0. It is talking about the charge, relative charge. So no unit. This is just a comparison. Comparing proton and electron, they roughly have the same charge, but opposite in direction. So proton +1 and electron is -1. Okay, and neutron is neutral, so 0. Next, relative mass. Again, just relative, comparing themselves. Okay, proton and neutron. Okay, comparing within themselves, around same mass, so 1. But for electron, we don't count the mass of electron because it's too small, roughly 0. We count it as 0. Okay, so this is because this table is quite important in counting the mass, okay, and counting the mass, because now you need to know, okay, of course for atoms it must be neutral. This is the definition. Atom must be neutral so that the number of protons is equal to the number of electrons, okay. Number of protons, that is equal to the atomic number. Actually, you know it. Atomic number is equal to the number of protons, and that is equal to the number of electrons, okay. And for the history, I think you can just skip it. Next, about atomic number, okay. Again, atomic number means the number of atoms in that element and means the number of electrons in that element, because atom must be neutral, okay. And every element has its unique atomic number, just like the identity number, okay. Hydrogen, atomic number 1. Helium, atomic number 2. Okay, so you need to know, for example, lithium, atomic number 3. So 3 proton, 3 electron. Okay, lithium, if the atomic number, okay, is 3, that means 3 proton and 3 electrons. And for example, a random element, for example, you have this one. Chlorine, okay, chlorine. The atomic number is 17, that means 17 proton, 17 electron. Next is the mass number. Guys, we use this symbol, okay? This symbol. Of course, right hand side, this is the symbol of the element, okay? And you have 2 numbers on top of the on top and at the bottom of the, I mean left hand side of the element. The top one, okay? The top left hand number represents the mass number. That means the number of proton plus the number of neutron, okay. This is the mass number. And the right, I mean for the bottom number, it is the atomic number. For the atomic number, it is the number of proton, number of electrons, okay, in the element, okay. So for example, this is helium, atomic number 4, okay. Sorry, atomic number 2, that means 2 protons, 2 electrons, and the mass number, okay, is 4. That means proton and neutron number is 4 when they add together. If you know proton is 2, so the number of neutrons in helium is 2. So for example, guys, okay, you have sodium, 23, we call it. The atomic number is 11. So 11 proton, 11 electron, and 23 minus 11 neutron. Okay, that means 12. This is how you read it. You just need to remember the position. Okay, 23. Okay, on the top left hand corner, it is the mass number. On the bottom left hand corner, it is the atomic number. If you don't mix it up, you won't have question. It's very simple calculation actually. And this is mass number. Remember, what contributes to the mass of the atom? It is the number of protons and the number of neutrons, okay? And the atomic number is just the number of protons and the number of electrons. It can represent both the number of protons and the number of electrons. So this is for this part. Guys, and you know for isotopes, okay, remember the definition, very, very important. Different atoms of the same element having the same number of protons but different number of neutrons, okay? I guarantee you will see it because it's so important. And guys, for calculation, okay, you need to know it, of course, but before calculation, the chemical and the physical properties. Isotopes will have exactly the same, guys, chemical properties, okay? For example, you have 2 isotopes of sodium. They will react with chlorine, of course, and they will react with chlorine at the same way. Okay, so you observe the same thing. Okay, 你見到呢個爆呢，呢個都會爆㗎啦。哦，呢嚿嘢加第二嚿嘢會爆喎。好啦，有第二隻 isotope 呢嚿嘢加落嗰嚿嘢度會點啊？一樣爆。Okay. For example, guys, okay, I just give you a very, very simple example. For example, let me see. For example, maybe I use sodium as example. Sodium we react with chlorine to form sodium chloride. You know it, okay? So if it is chlorine, if it is sodium 23 react with chlorine, of course it will form sodium chloride with the sodium 23. And how about 24 sodium or sodium 24? When it reacts with chlorine, it will form sodium 24 chloride. Okay, it is exactly the same. You will see exactly the same thing. You can't tell the difference. For chemical property, okay, for chemical properties, they have exactly the same chemical properties because they have the same number of electrons. And for speaking of the physical property, because their mass is a bit different, because they have a number of neutrons are different, so their physical properties are not the same, okay, a bit different. For example, water and heavy water. D2O, the word D means heavy hydrogen, okay, deuterium, heavy hydrogen. Of course, no need for you to remember D is deuterium, but you can know it. You can treat it as normal water and heavy water. Okay, normal water melting point 0 degrees, but for heavy water the melting point is roughly 4 degrees Celsius. They are not the same, but both water and heavy water, okay, they have exactly the same chemical property. Okay, and for hydrogens and deuterium, that means normal hydrogen and heavy hydrogen, they will have exactly the same chemical property because they only have both of them have only 1 electrons. They have the same number of electrons. So this is the physical and the chemical properties of isotopes. Next, guys, the calculation. Okay, for the definition, I don't want to recall it. Okay, you just need to remember it is relative to the carbon-12 scale. We define carbon-12, the mass is 12. So actually, it is 1/12. Okay, this is the scale because carbon-12 is 12. So you need to multiply by 1/12 times the mass. That means you divide it by 1. Okay, and this is just relative. Okay, this is just a relative concept. And atomic mass. Okay, you need to calculate all the isotopes. I don't think I need to go through it because you can easily recall by reading the question again. Go to revise by reading the question again. Okay, make sure you know how and why this happens. Okay, especially for this one. Okay, it's really important, girls. It's really important. Okay, if we know one, all of them, all isotopes add together, it must be 100%. All isotopes add together, it must be 100%. Okay, so now this time we have 3, we give you 1. So this 11% plus these 2 will give you 100%. So you just need to do the basic percentage. Of course, it will be easier for you to use the one in blue, easier to understand. Okay, easier to understand, and you find it. Remember, guys, in percentage. Okay, you need to leave this as your answer, but not just leave the calculation always 1 or 2 marks only. Okay, but each answer carries 1 mark, so it is more important. Last but not least, guys, okay, is the drawing of electron diagram. Okay, drawing of electron diagram. And again, okay, this is the capacity of the electrons. And guys, remember, when you draw the electron diagram, there's no need for you to add additional circle. Okay, you know the first shell contains a maximum of 2 electrons. The second shell contains a maximum of 8 electrons. The third shell contains a maximum of 18 electrons, but calcium and potassium are exceptional case. Okay, and if you know how to draw, you should know the electron arrangement. Okay, girls, just pay attention. Okay, again, no need to draw it that beautiful, but you need to pay attention. Every circle is the electron shell. Okay, and remember, first shell maximum 2 electrons, second one maximum 8 electrons, third one maximum 18, fourth shell maximum 32. But for elements of potassium and calcium, okay, we don't go to the third one. We don't continue. After argon, the electron arrangement is 288. The next one, it is atomic number 18. Okay, for potassium, girls, it is not 289 but 2881. Okay, because of some special reasons, because of the energy. Okay, but now it's too difficult to tell you. Okay, anyway, for calcium it's 2882. So that's all for chapter 5. Remember, girls, again, drill more on the calculations. Drill more on calculations, especially for this type of question. Okay, you should be familiar. Okay, even though it is simple calculations, but please be aware for making careless mistakes. So for chapter 6, I will use another video to talk